Right, so I'm gonna be honest with you and tell you that this, to me, is kind of confusing. So what I did is made up this cheat sheet for you guys. And I'm hoping that this helps. And then whenever I give you guys a cheat sheet, you can use that on the quiz. Okay, so we do, I want to say the first 4 sections and then we take a quiz, so you'll be able to use this on that. Okay, so what we are going to do today is we're going to talk about functions. We're going to talk about something with them being one-to-one and on-to, and that's what I think is kind of confusing. We'll see what you guys think. So when they give you something today, one of the ways they can do it is give it to you as a set of ordered pairs. So let's say they said an ordered pair is 2, 3, one is 4, 5, and one is 6, 7. Okay. One of the things they'll ask you today is to list what is the domain and what is the range. The domain is going to be your X values. Okay, so your domain would be 2, 4, and 6. And usually you'll notice if you look, they put it in like brackets. That's not a huge deal, but typically they do. Then they'll ask you for the range, and the range is your Y values. Okay, so that would be 3, 5, and 7. Okay. Then they will ask you, so this right now is what's called a relation. Every set of ordered pairs, you'll see what a mapping is in a little bit. Every mapping is a relation. Every graph is a relation. What we're going to determine today is this a function? Okay. And so when you look at this cheat sheet here, there's going to be 3 different ways that they present you material or data. One is with ordered pairs like here. One is a mapping, and you'll see what that is, and one is a graph. And then if you look at that first column, that is how you can tell if something's a function or not. And for each of them, I put how to tell if it's a function. The next column is how to tell if it's one-to-one, and we'll talk about that in a second. And then the last column is how to tell if it's onto. Okay, so for something to be a function, every X has to be different. So every X has to be different in your ordered pairs. So if you were to look at mine, notice all of these are different, so that would be a function. Okay, so if this is kind of what a mapping looks like, sometimes you'll see it with like circles around this, but that's what a mapping is. And with a mapping, every X can only have one arrow drawn from it. So here, there's only one arrow drawn from every X value, so that is a function. Okay. Here is a domain and a range for this. Okay. Typically, when you list a domain and a range, and again, this isn't something you get marked wrong for, but typically, if you were given the domain, you would write them from smallest to big. So they put -2, 2, then 4, then 5. Okay. Then for the range, these are your Y values. So again, they put it from small to big. Okay. So that's if they ask you just to list your domain and range. Domain is the left side, range is the right side. So here's another mapping. And notice on this one, there's 2 arrows coming from the X value 4. So that would mean it's not a function. Okay, so for something to be a function in a mapping, every X value can only have one arrow coming from it. Okay, So now is where we're gonna talk about what is one-to-one, what is on. And this is what I think is kind of confusing. Let's see what you think. So first of all, for these two to happen, you first have to determine if it's a function or not. If it's not a function, then you don't have to worry about one-to-one or onto. Okay? For one-to-one, each x has to go to a different y. Okay? So notice each x is going to a different y. If I looked at this one, again, these two are okay. 3 goes to a C, but 4 goes to the C also. So for something to be one-to-one, each x has to go to a different y. Does that make sense? So this one is one-to-one. For onto, how you determine for a mapping if it's onto is each y has to have an arrow drawn to it. So we don't care about our x's when we're looking at onto. We're looking at our y, and every one that's listed has to have an arrow drawn to it. Now, if I look over here, this is not onto because that C does not have an arrow drawn to it. Okay? And then there's functions that are both one-to-one and onto. And in these, you'd have to have every x has to go to a different y. So you couldn't have two arrows coming from any of these. And each y has to have an arrow to it. So if I added a letter E down here that didn't have an arrow, then it would not be onto. So again, this is your kind of cheat sheet that you'll be doing. And each time, if I give you an ordered pair, you're going to look at, is it a function? If it's not a function, you don't worry about these two. If I give you a mapping, you look. I give you a graph, you look. Okay. With a mapping, okay, for it to be one-to-one, notice each x can only have one arrow drawn from it. So, or no, I'm on the wrong. One-to-one is right here for the mapping. Each x has to go to a different y. And so this would not work for one-to-one because all three of them go to the same y. For this one, notice each x does go to a different y. My y's only have one arrow coming to it, so that's good. For onto with a mapping, that's this one. Each y has to have an arrow drawn to it. And so if you look here, this y doesn't have an arrow, so that's not onto. For this one, this y has two arrows drawn to it, so that is okay. Every y has an arrow drawn to it, so that's okay. Even though it has two of them, that's all right. So here's just some terms that you'll see throughout this chapter. One of the things they'll ask us to do today is draw straight lines and graph. And then we'll also have nonlinear functions. So one of the things you'll do today is graph just like you did on your test yesterday, where you'll have a line, and that is called a linear function. And then we'll also have things that look like this, which is called a parabola. Now, this is said to be nonlinear. Okay, so independent versus dependent, just so you've heard these words, your independent value is always your x, your dependent is always your y. We will see things today that are like y equals 2/3 x minus 4, okay? That is what's called the linear notation. And as we go through, you're going to see where they replace your y with f of x. F of x and y really are the same thing. This just means that it is a function with x as your variable. Okay, but y and f of x are used interchangeably. They mean the same thing. Okay, this is function notation, this is linear notation. So this is something that you did in algebra. This is not bad. They will give you a line today and they'll ask you, is it a function? And you probably have learned the vertical line test. And the vertical line test is where you can either imagine or actually draw vertical lines through it. And if your vertical lines only touch your graph in one point, then it is a function. If I go to this one, if I kept drawing vertical lines, notice I always only touch my graph once. So that is a function. So this one was, this one is. If I go to do that vertical line test here, if I draw vertical lines, notice I touch the function twice. So this is not a function. So the graph ones, to tell if it's a function, you use the linear or the vertical line test. Now, another thing that they will ask you today is they'll have you maybe graph something or they'll show you a graph. And they'll ask you if it's a discrete relation or a continuous relation. And discrete just means that you're going to have points. You're not going to have a line through them. That's what discrete means. It's kind of like a scatter plot. Okay. With continuous, it's just going to mean that you have a line through it. And it can even be, it doesn't have to be a straight line. It can even be like a parabola. That's still considered continuous. There's just a lot of information in this. So again, here's your cheat sheet. And this is the first type of problem you're going to have. So they're going to give you a set of ordered pairs, and they're going to ask you to find the domain. Does anybody remember what the domain would be? Domain would be your x's or your y's. It's the x's. So what you would do here is just list your x's: -6, -5, -3, -1, and 6. Okay. Then with the range, you're listing the y values. So that's not bad either. And here's one thing. I didn't list from small to big. Really should have. Let me redo that actually. You don't have to do that, but for my notes, I will. It makes it easier, like for grading, to go from small to big. Oh, and let's see. These were from small to big already. Sorry, like I told you. Sorry. But if you didn't have them from small to big, that's fine. Now, when you have two of the same y value, you only list it once. So if I name these from small to big, I'd go -9, -7, -1, and then 7. So when you have the same value twice, you don't list it twice, you just list it once. Okay, so we have a set of ordered pairs, and it is asking us, is it a function? So you're always going to be looking at here, we have ordered pairs, is it a function? All of your x's have to be different. And if you look, every one of our x's is different. So that means, yes, it is a function. If it wasn't a function, you stop right there. So you're going to like the ones that aren't. Then it's, is it 1-to-1? So if we go up to the ordered pairs for 1-to-1, each x has to have a different y. Does each x have a different y? No. We have 2 -9s. So that means no, it's not 1-to-1. Okay. And by the way, when you're doing your assignment, they won't have these questions here, so you might just want to look at your notes. They'll just have you, list the domain and the range. I just put these to kind of help us, so you can kind of take a peek at that. Is it onto? So for an ordered pair with onto, so if it's a function, it's always going to be onto. So if you have yes for a function, you automatically have yes for onto. And then, so like, again, these are just kind of guiding questions. This says, is it both one-to-one and onto? No. And how you write your answer for this, once we figure this out, we would say that it's a function. And we would say that it's onto. That's what we figured out. So now we have a mapping. And with our mapping, the domain is going to be the ones on the left. And like I said, you really should write them from small to big. So we're going to go 5, 10, 15. And then your range is going to be your Y values, which was 105 and 110. And then is it a function? So we're going to go to our cheat sheet again. For a mapping to be a function, every X can only have one arrow drawn from it. Every X can only have one arrow drawn, and that's true, right? Each one has one, so yes, it is a function. And then is it one-to-one? So for a mapping to be one-to-one, each X has to go to a different Y. Is that true? No. That one goes to 2 or 5 and 15. So this is no. And for a mapping to be onto, each Y has to have an arrow drawn to it. So you couldn't have, what they mean by that is, say you had 120 down here with nothing, that would not be onto, but these both have arrows, so this is yes. And then again, it's not both. So what you would write for your answer for this one is that it is a function. And the function is onto. Then if we go down here, if they give you this, this is just like giving you a list of ordered pairs. Okay, so with this, what you would do is for your domain, you would just write down your X values. -1, 0, 1, 2, 3. For your range, you'd write down your Y values. So -5, -3, -1, 1, and 3. So when they give you a table, that's the same as giving you ordered pairs. Okay. So when I look at this, for a list of ordered pairs to be a function, all X's have to be different. So if you look, do any of these repeat themselves? They don't. So yes, this is a function. Then for ordered pairs to be one-to-one, each X has to have a different Y. Each X has to have a different Y, and these are all different. So yes, it is one-to-one. And then if you remember with ordered pairs, every ordered pair that is a function is always going to be onto. So if you have ordered pairs and it's a function, it's going to be onto. So when you write this, it is both onto and one-to-one. So you could just say function and both. Or you could say function, one-to-one, and onto. now, if we look here, this is kind of the same. So here we have a mapping and they want our domain, which is 2,8. And for the range, we have 21, 25, 30. So this is a mapping. For it to be a function, each X can only have one arrow drawn from it. And if you notice right here, the 2 has 2 arrows drawn from it. So then it's not a function. And when it's not a function, then it's not this, and it's not that. So what we would say for that is we could just say no or not a function. So like I said, you're gonna like the ones that are not, because you just answer it and then you're done. Okay. So you look down here, a table is just like a set of ordered pairs. And they first want the domain. And again, if you have 2 of the same, you only list it once. So it's -2, -1, 1, and 2. For the range, that's these values. And if you have something listed twice, you only write them one time. So we have a -1. And then if writing from small to big, we have a 0, and then we have a 1. Now, for an ordered pair or table, we're going to look, is it a function? For it to be a function, all X's have to be different. And if you notice, they're not. You have 2 -2s. So this is no. So you can stop right there and just say not a function. Do you think it's bad so far? That's the worst of it, in my opinion. Okay, so let's look here. This is where we have a graph. And with a graph, you have to see first if it's a function. And I talked about that. Well, for something to be a function, you want to either draw vertical lines or kind of visualize vertical lines and see, is that vertical line only going to touch the graph in one spot? Okay, so this is a function. Any diagonal line is going to be a function. Then this specific question asks us if it's onto, but let's just talk about one-to-one also. For one-to-one, you have to do a horizontal line test and see if it only passes through one point each time. So what you're going to envision here is if you drew horizontal lines, does it only pass through once? Yes, it does. So it's one-to-one. And then for it to be onto, every Y has to be used. So what that means is this graph covers the whole graph here, okay? So if you kind of envision like 10 has a point, 8 has a point, 6 has a point, and going across every point here, there is a Y coordinate for everything on that graph. So that means, yes, it is onto. Okay. So now let's go here. Okay, so first this asks us to graph this. So what I'm gonna do is just graph it using its slope and its y-intercept, because you guys are used to that. So we're gonna go over here. We're gonna go to the y-intercept, which is -1. And then we're gonna go up 2 over 3. 1, 2, 3, up 2 over 1, 2, 3, up 2 over 1, 2, 3, which is the same as down 2 over 1, 2, 3. Okay, so, and again, For these, you can grab a sheet of graph paper and your ruler and then draw that line. Now, when they say domain for a graph, what they're asking for, whenever you guys hear domain, think domain as what x's does your graph work for. So if you look across for the x's, notice for every x, there is a y. So that means it's all real numbers is what the answer is. So for every x, there is a x coordinate on, or a y coordinate on that line. For every x value, there's a y. What it would look like if it wasn't, is it would be like a sideways parabola where like -10 might not have any points. So like if the parabola started here and opened up this way, none of these have y values. So that's what would look like if it wasn't a function. For the range, what they're asking, and you got to think about this continuing forever. For every y, would there be a point on the graph? And there would be. For every y, because this keeps going, there would be a point on the graph. So again, how you write that is all real numbers. And you can write out all real numbers too if you want to. Then, once you get to that point, you're going to use your cheat sheet again. To see if a graph is a function, you do the vertical line test. Any vertical line is going to cross just in one point. So yes, it is a function. Is it 1-to-1? That's where you do the horizontal line test. So if you did horizontal lines going across, that's also going to only hit at one point. So that's yes. And then for it to be onto, every possible y in your range has to be used. So this is what this means. Our range is all y's. And this is asking you for all of your y's, is there going to be a point on the graph? And there is. Every y going across is going to have a point on that line. So this would be onto. And so it would be both. And then is it discrete or continuous? This is a straight line and it's got a line through it. So that means it's continuous. If it was only dots on the graph or points on the graph, then it's discrete. This one has a line, so this is continuous. So here again, they wouldn't have these questions. So you would want to say that it is a function. And it's both 1-to-1 and onto, so you could just say both. And then it's continuous. Now, if we go to this page, here, whenever you have like x squared or y squared like that, it's going to end up being a parabola. And to graph those, you have to make a table. So what we're going to do is make an XY table. And usually what I do when I'm graphing a parabola is I'll put in -2, -1, 0, 1, and 2. Okay. Now, if you're somebody that would rather just punch something into a calculator, you can do that. But when you put the -2 in here, it's very important that if you punch that in, you put the -2 in parentheses before you squared it, and then do +1. If you just typed in -2 squared +1 without parentheses, you get it wrong. So when you square a -2, do you guys know, would you get a -4 or a +4? It would be positive. When you square a negative, it's positive. So this would be 4 plus 1, which is 5. When I go -1 squared plus 1, again, when you square a negative, it's positive. So that would be 1 plus 1, which is 2. When I put 0 in there, 0 squared is just 0. 0 plus 1 is 1. And then when I put 1 in there, 1 squared is 1. 1 plus 1 is 2. And then when I put 2 in there, 2 squared is 4 plus 1 is 5. So then I can go to my graph and I can plot those points. So at -2, I'm up to 5. At -1, I'm up to 2. At 0, I'm at 0. At 1, I'm up to 2. And at 2, I'm up to 5. So what my graph would look like then is like this. Okay. Then they are asking us for this. What is the domain? That means what X values will this graph work for? And you have to think about that parabola keep going forever and ever and ever. So it would work for every X value because that would just keep going forever and ever. So all of your X's are going to work. So that's all real numbers. Okay. Your range is what Y values work on the graph. And notice down here, none of these Y's have a point on the graph. It's only the Y's that are greater than or equal to 0. Those are the Y's that have a value or a dot on the graph. So our range would be Y that is greater than or equal to 0. It has a point at 0, and then it has a point at each Y going up. Okay. Then they ask us, is it a function? And remember on a graph, to see if it's a function, you do a vertical line test. So if you thought of a vertical line test, it would work at all of those. So this would be a function. For it to be 1-to-1, you would do a horizontal line test. And again, you'd only want your horizontal lines to touch the graph one time. But notice here, it would touch the graph twice. So that is not 1-to-1. And is it onto? This is a little bit confusing. For a graph to be onto, every Y in the key here is in the range has to be used. Not every Y on your graph, every Y in the range has to have a point. So for every Y greater than or equal to 0, there has to be a Y value. So it's not every Y on the graph, it's every Y in the range. So this one would be yes. And then is it both? No. And is it continuous? So a discrete, again, that has a curve going through it. If it was discrete, it would only have dots. So this is continuous. So how we would write our answer then is that it's a function and it is onto. And then that it's continuous. Okay. Then if we go to this page, this one's already graphed out. And it says, what is the domain? So this has a parabola facing down. The domain is what are your X values? And if you think of this, keep going forever, every X would have a point. Okay. So this would be all real numbers. And I believe every one that you do, your domain is going to be all real numbers. Okay. For the range, You're looking at what Y values does it work for? So notice this point right here as a Y would be 9. So this Y value on here would be 9. So over 2 up 9. So this would work for all Y values less than or equal to 9. Less than or equal to 9. So if you notice at 10, there's not a point. At 11, there's not a point. At 12, there's not a point. But for 9, 8, 7, 6, everything less than 9, there is. For it to be a function, you would do the vertical line test and it would pass. So yes, it is a function. Is it 1-to-1? You would do the horizontal line test. And if you did a horizontal line right here, it would touch twice. So it would not pass a 1-to-1. Is it onto? So that's where every possible Y in your range for Y is less than or equal to 9. Every one of these Y's has to have a point on the graph, and it does. So it's onto. Is it both? No. Is it discrete or continuous? Because this has a line through the points, it is continuous. So your answer for this one would be that it is a function and that it is onto. Okay. So your assignment then is this. Did it make sense? Did you understand it? Was kind of confusing. Use that PT, and then you can also use the PT when we take our quiz and text.
Exactly.